let's start talking about transition matrices. So, a transition matrix describes a situation where transitions are made between two states. So, transitions are changes. So, and two states. So you can imagine a state being the way things are 1 week, and then next week there's a change, there's a transition. So that's week 1, week 2. Okay, so that's what happens. We're talking about these these changes, and all of that can be modelled with a matrix. Now, we model it with a matrix. We also use diagrams. Nice little picture to show it, and then we can also use a matrix to help us make predictions and so forth. So let's look at this example I have here. A group of delivery trucks transfer goods between two warehouses, A and B. The trucks start the day at either warehouse and finish the day parked at one of them. So they start the day at either A or B, doesn't matter which, and then at the end of the day, they end at either A or B. If they start at A, they don't have to end at A. If they start at B, they don't have to end at B, etc., etc. 70% of the trucks that start at A will park at A that night. Okay, we'll park at A that night. And 30% will park at B. Okay. 60% of the trucks that start at B will park at B that night, and 40% will park at A. So we can see that via this diagram here. So this is warehouse A. So 70%, 0.7 as a decimal, started at A and end at A, and that's what that little loop there is saying. Okay, 70% start at A, end at A. 30% that start at A will end at B. And that's what that that line is showing there with the little arrow. 60% of the trucks that start at B will end at B. You can see with that little loop there with the arrow and the decimal indicated there, we can write in decimals or percentages. I think it's far more usual in diagrams to use decimals. In our matrices, we definitely use decimals. And then 40% will park at A. So you can see they started at B and then will end up at A. So trucks can be in either of two states, at warehouse A or at warehouse B. Okay? Now, we can also represent this diagram as matrix T for transition. So you can see I've got the starting at A or B and ending at A or B. So 70%, 0.7, that start at A, end at A, and 30% or 0.3 that started at A, end at B. You can see also that 40%, 0.4 that started at B will end up at A. The next night will be at A. And then 60%, 0.6 that start at B, the next night will be again at B. Now, the thing you absolutely have to take note of is that these columns add up to 1. You can see they add up to 100%. Okay, so they add up to 1 for 100%. That's what the columns add up to. So for every transition matrix, the columns of the matrix add up to 1. And in the matrix, we represent this as a proportion, not as a percentage, i.e. as a decimal, not a percentage. Okay, so we always use the decimal, not the percentage. Alrighty. So let's look at an exam question. So this is from the 2018 exam 1, question 6. So middle to hard grading of the question. A transition matrix V is shown below. So V, this month, next month. So this month, where they've started at, where they will go to next month. Okay, where they've started at, where they'll go to next month. And we've got all our percentages here. The transition diagram below has been constructed from transition matrix V. The labelling in the transition diagram is not yet complete. Okay, so you can see here that there's gaps. There's gaps we don't know, or they haven't put in all of those. We are asked the proportion for one of the transitions labelled X. The value for X is. Okay, now we've got to do a lot of workings backwards here because we haven't even got what these points are. So let's look at that and try to work this out. Okay, so what do I know about this point? I know that point 4 will leave that point to go to another point. And looking through here, I'll go, okay, well that's M to F, isn't it? That's got to be M. I'll write that there. I'll write that again. Not having good luck today, so M, that's a bit better. Go to F. You can see there that M to F is 0.4. Okay, now 0.1, M to T, isn't it? So, and just to double check, I'll write this as T. And we also know that, okay, 0.2 from T to M, does that make sense? From T to M. Yes, that makes sense, that's 0.2. Okay. So that means that this point, if we know that's M, F, T, that has to be L, doesn't it? Okay. So X is the proportion that this month is at L and next month will also be at L. So this month is at L and next month will be at L. So that should be 0.6. Now we can fill in the rest, and I might go and do that in a second. Let's just look at these questions, these results. So yes, C 0.6, yep. And 81% of the state answered correctly, and 8% answered B. That was the next highest correct answer. So looking at this, I'll fill the rest in so we can understand it a bit better. Going from L to F, 0.3, start at L and then go to F next month. So that would be 0.3. And what's it? So F to L is 0.2. So 20% that were at F this month will be at L next month. And for these two, so for T to L, that is 0.6. So 60% of those started at T were at T this month, will be at L next month. And L to T, 0.1. Okay. Now you can see there's a few zeros in there. That means that there wasn't any movement between those two states. So between L and M, you don't go from L to M. So that's why they can't be linked on this diagram. There's no line between them. And you can see that also there. You can't start at T and go to F because there's no line in between. F to T, yep. Yeah, and M to L. You can also see that although you can go M to F, you can't go back from F to M. So F to M, like 0 there. So there are a few other little clues in there to help you figure this out. But you really need to look at the numbers you've been given in the matrices and understand that diagram.